It's just the same idea. So make the big dot, not a little dot in your working, because I need to be able to see it. Okay, so it's a universal rule 5. Anything multiplied by 0 is 0. So let's just do this quickly. S 0 times 0. From this rule here, straight away, I can just say from Q5, that's 0. Now, building on your point from earlier, let's say instead of this, we had 0 times SS0. We can't use this rule because we're not multiplying by 0, we're multiplying by 2. How big is this number? We have no idea. We can't do that one yet. So when it says x times 0, it does not mean 0 times x. The order really matters. And this will be a pain. But this is there for all sorts of important and or historical reasons. But we need to multiply by numbers that aren't 0, so we need to have a rule for that. X times, well, if it's not 0, it's going to be the successor of something, right? What x times the successor of y? So there's something to do with x times y. What else do we need? Another x, yep. So we're adding on the other x. So we've reduced it to smaller numbers which we can break down further and further. And if this number was 2, actually let's just play with that one because we've already had that earlier. 0 times 2 is equal to, by this formula, that's the successor of 1. But this first x, which is 0 plus 0 times 1, that's by Q6. 0 plus, let's break this down, 0 times the successor of something, 0 times the successor of something, that's 0 plus 0 times 0 by Q6. Okay, what's 0 times 0?
0.
It's 0 by rule 5. So that's 0 plus 0 plus 0 by Q5. 0 plus 0 is 0 by rule 3. 0 plus 0 by rule 3. And 0 plus 0 is 0 by rule 3. We've shown that 0 times 2 is 0. That's a whole lot slower than the other way around, right? 2 times 0 is easy to work out, 0 times 2 is hard. We broke it down to simpler things which all turned out to be 0. Often they turn out to be bigger numbers, and this time they all turned out to be 0. We added them all up. So that's how we do multiplication. Those are the 6 rules that I usually teach. 0 being consistent, I add a new rule. Which, well, no, he doesn't. He's advised it. He thinks it's useful. He didn't used to teach this old rule either till a couple of years ago. He's keen on it. 0 is the only non-successor. All of these rules here, you can have a 0, you can maybe say, let's have 0 and a half. And you've got like 1, 1 and a half, 2 and a half. And a half isn't the successor of anything. So we could just do that, and now we've got some sort of system where we've got zeros and halves. And we can do some fractions. We're not going to allow that. So our last rule, which needs to be in black like the others, everything is 0 or a successor. Every number, that's 7, not a unit, not a residual. Every number is either 0 or there exists some number which it's the successor of. This also stops, yeah, okay? So that's fine. Now you might think, hey, that means we're going to have like a negative 3, which would be the successor of a negative 4, the successor of negative 5, and keep going. But one problem with that, what's the successor of negative 3? 2. A negative 2. What's the successor of negative 2? Negative 1. What's the successor of negative 1? 0. Can't have that. First rule. So we can't have negative numbers, we can't have fractions. We're only doing whole counting numbers. The first set of rules worked how to do whole counting numbers, and this says, and there is nothing else. I'm crossing my fingers on that. What I said was strictly not true. You can get numbers in if you're particularly cunning.
Can you repeat it?
Can I repeat this?
Yeah.
This says every number is either 0 or is a successor of some number. So that's no negative numbers, no half numbers, nothing like that.
You have like some loop which is independent of the rest of the numbers?
So, yes, you can. So you can have, just drawing timelines, or lines, number lines, 0 and onwards. And this thing here, which is a bunch of successes going round in a loop. That is also fine. Because either number is a 0 or it comes after something. That would be true if we have these numbers. We'd need to say something like, for all numbers, there's a number of times you can go back before you get to 0 or something like that to heat them up. Also, just if we're going to screw with people's heads, you started it, I'll finish it. You can have an infinite line, as long as it keeps going infinitely. That's a half, that's minus a half, minus 3 halves. There's always successes all the way through. It never touches 0, so it doesn't clash with the 0. And everything has a successor because it goes on for infinity backwards and forwards. So this rule still isn't enough to guarantee we've got the whole numbers. Let's